Hi everyone, today we're looking at an O-level type question on kinematics, or in this case, speed-time graphs. And so before we jump into the question, really, I just want to recap a little bit. When you think of a speed-time graph, really the first thing, or the first few things you should think about is what you can do with them. So let's say you have a speed-time graph, whatever it is, okay, it can look like anything. And the first thing that I think of is that the gradient gives me the acceleration. Acceleration is how much the speed is changing with respect to time. So it tells me as time changes, how much the speed is changing, which is the gradient. Okay, and then the next thing I know is that the area under the graph gives me my distance. Right. And so I won't go through a full derivation, but we're just going to use these two results to solve this question. And please note, this is for a speed time graph. For distance time graphs, it is a different set of rules, a different set of outcomes and results. So for the speed time graph, which is what we're looking at right now, we can see, okay, the speed looks like this. 15 seconds, it goes up and then stays the same, 50 seconds, it goes down. Calculate the deceleration of the bicycle in the last 30 seconds of the journey. So let's try to see last 30 seconds of the journey, where is that? Okay, so the journey ends here. So 90 minus 30 gives me 60. And so, really, I should just note over here, there's some 60 over here, and the question is asking me to find the deceleration for this section, and then we look for deceleration. What am I looking for? It's the gradient. And maybe over here it would help to just take a look simply, to put in simple terms, because there's deceleration, acceleration, what's the difference? So just think of it this way. Ask yourself, is speed changing? If the answer is yes, then there is some kind of acceleration. Then you ask, if the speed is changing, no, that means acceleration must be 0. It must be 0. If speed is changing, there must be some kind of acceleration, and then you ask, is speed increasing? If it is, then in simple terms you can say it is accelerating. And is speed decreasing? If speed is decreasing, then in this case you call it deceleration. So of course you can go into even more technical terms and all, but I think for simply O-level math, usually this will work. Okay, so let's go back here, and you see, okay, calculate deceleration. So you can ask, is speed changing? That's the first question, right? Is speed changing? Yes or no? So let's look. Is speed changing in the last 30 seconds? Speed. Well, over here it was this number, maybe like 14. I don't know what it is, around there. And then it keeps decreasing, right? The speed itself keeps decreasing. So is speed changing? It decreases to 0. Yes, speed is changing. Then let's look. Is the speed increasing or decreasing? Oh, it decreased. So it's deceleration, right? So that makes sense then. That's why it's asking, calculate the deceleration. And then now you want to calculate the deceleration, so it means the gradient. You want to find the gradient. Then you think of it as, oh, but I don't know this point. To find the gradient, I just need 2 points. I know this point. This point is 90 and 0. This point is 60, but I don't know this. I actually don't know what this value is. The good news is that for a straight line, and this line is actually part of this entire line, the gradient is constant. That means I don't actually have to use this point. What I can do is I can take this point instead, 50 and 15. And because the gradient on a straight line is constant everywhere, so I can take any 2 points. I don't have to use that specific point. So there you go. I can just go ahead and find my gradient, whereby this is x1, y1, and this is x, oops, x2, y2. And so the formula gives y2 minus y1 over x2 minus x1. This is my gradient. And so y2 minus y1, 0 minus 15. And x2 minus x1, that is 90 minus 50. And that gives me negative 3 over 8. And since this is like a physics kind of question, I don't like to leave it in fractions. I'm going to convert it to decimal. Yep, and the thing is this is negative. Why is it negative? It's because it's decreasing, because it's deceleration. But since the question asks for the deceleration itself, and in the word deceleration already suggests that there is a negative sign, because the negative sign tells us it's slowing down. So since it's already asking for the deceleration, the deceleration tells me that it knows that it's slowing down. So I don't have to take into account the fact it is slowing down. So I can just go ahead and drop the negative sign and just write 0.375. Yeah. As a side note, if the question asked not for deceleration, but if it asked for the acceleration, then I need the negative sign to tell the person that it is decelerating, it is negative, it is slowing down. If they ask for the acceleration, then I must tell them it's a negative acceleration, that means it is deceleration. But since in this case the question already says, I know it is slowing down, I know it is negative, you don't have to tell me it's negative, it's deceleration. So I just drop the negative sign and I give it just the number. Now, part B, calculate the total distance traveled on the journey. So over here, total distance traveled on the journey, it is the area. And so we're trying to find the area, total distance. So basically, we're just trying to find the total area under the whole curve, this entire chunk. Okay, and how do we do it? Let's split it into sections. And so for the first section, let's do this part. And then second section, we shall do this centerpiece. And then for the third section, we shall do this part. Okay, so let's do the red one first, the area. So the area is a triangle that looks like this, where this is 15 and this is also 15. Am I right? Yes, so area is half times base times height, which gives me 112.5. And then now let's do the yellow section. So the yellow section looks like this, where it's 50 and 15 over here. So if I take 50 minus 15, that gives me 35. That's my length. And then my height is 15. So the area for this one is simply 15 times 35, which gives me 525. And now let's do the pink section. And the pink section looks like this, where it's 50 and 90. Okay, so it looks like this, where it's 50 here and 90 here. So this distance is basically 90 minus 50, which is 40. And the height is 15. And so the area is half times base times height. And this gives me 300. And so there we go. We can now add up the whole, all the areas. So we have 112. Sorry, lack of space. 112.5 plus 525 plus 300, and the result is 937.5 meters. And of course, if you want to round it to 3SF, then we would say it is 938 meters in 3SF. So you can just write it down there. There you go. Okay, now for part C, the maximum speed of the bicycle was 15 meters per second. And we want to convert 15 meters per second into km per hour. So for this part, let Let me show you how I like to convert units. So let's do 15 meters per 1 second. That's what it means. In every 1 second, you traveled for 15 meters. And we want to eventually convert it to km per hour. And it's honestly pretty complicated if you try to convert it all at once to km an hour. So let's just convert to km first and leave the denominator in seconds. So it's 1 second, it's still going to be 1 second. Can we convert 15 meters to kilometers? And so we think about it, we have 1,000 meters equals to 1 km. In this case, we want 15 meters eventually, and we want to know how many km that is. So let's convert to 1 meter first by dividing by 1,000. So we also divide by 1,000 on the right hand side. And then over here, we multiply by 15. So over here, we also multiply by 15. So this is actually 15 over 1,000. So 15 over 1,000, it also gives me 0.015. So this is really 0.015 km in 1 second. And then the next step is we got the numerator to km. So let's convert the denominator to hours. So we have 0.015 km. We want to convert seconds to hours. And how do we do that? Then we look at 1 hour as how many seconds. So we think we have 60 minutes in an hour, and each minute has 60 seconds. So we have 1 hour equals to 3,600 seconds. And eventually we want how many seconds? We want 1 second. We're trying to convert 1 second into how many hours. So let's see, we want 1 second over here, so we can get there by dividing by 3,600, and so we can get this by taking 1 hour divided by 3,600, and that means 1 second equals to 1 divided by 3,600 hours. So let's just key that in, hours. And I didn't convert to decimal because it's quite an ugly recurring decimal. What I prefer to do is just key this into my calculator. Or if you prefer, you can key something like this, divided by, and then put a bracket, 1 divided by 3,600. So the calculator knows how to do this part first, because you must do this part first, and then it takes this divided by this. So it takes this divided by this. And if you key that into your calculator, what you'll get is 54 km per hour. 54. And there you go.